Okay, another problem, simplifying square roots. Okay, one of the rules I mentioned yesterday was that you cannot have a radicand that is a fraction. Okay, by that I mean a fraction that where the denominator is not equal to 1. So in this case we're simplifying square root of 2/3. What I like to do next is to take this fraction and rewrite it as 2 square roots. Square root of 2 over the square root of 3. Now I have two radicands, and both are integers, so that takes care of the first problem that we had a fraction for a radicand, but it creates a couple of other problems. We first of all have two square root symbols in one expression. That's never simplified, and we have a square root in the denominator, and that's the other rule that we have to take care of. So as explained in class, we can multiply anything times 1 and it doesn't change the value. So what we're trying to do here is change the appearance of the expression, not change the value, just state it a different way in a simplified form, that is. So we're going to multiply by 1 as a fraction. Now any fraction where the numerator equals the denominator, any fraction like 1 over 1 or 10 over 10, they're all equal to 1. As long as the numerator equals the denominator, it's equal to 1. So the fraction that I always want you to use, for now anyways, is whatever you see in the denominator of this expression, just make a fraction out of it where that is the numerator and denominator. Because square root of 3 over square root of 3 in this case is equal to 1. So we're taking square root of 2 over square root of 3 and we're multiplying it by 1. So we're not changing the value, we're just going to be changing the appearance. Now for the next step, we're multiplying two square roots in the numerator. So just like when we simplified square roots and we said something like the square root of 50 equals the square root of 25 times square root of 2, if we break up a number into two factors and it's equal to what we started with, we can multiply these two irrational numbers and we get square root of 2 times square root of 3, therefore has to equal the square root of 6. And we technically can do the same in the denominator. We can say the square root of 3 times square root of 3 equals the square root of 9. Now a lot of math teachers don't like that because the square root of 3 times itself just by definition should give you 3. The problem is a lot of high school sophomores don't recognize that, but they recognize that if the numerator, square root of 2 times square root of 3 equals the square root of 6, then it would only make sense that the square root of 3 times square root of 3 for the denominator equals the square root of 9. And it does. But the square root of 9 is equal to 3. So therefore we just copy over the numerator and look what we have. We have an expression and it satisfies all three rules. There is a radicand, it's a 6. There's no perfect square that divides into 6, so that rule is taken care of. There's no square root symbol in the denominator, so that's taken care of. And yes, we technically have a fraction, but the radicand, 6, is a whole number, so therefore that rule is taken care of. So therefore, square root of 6 over 3 is equal to what we started with, the square root of 2/3, but the square root of 6 over 3 is the simplified version of that because it satisfies all of the rules that we've gone over. One more example for today. We have simplify 10 over the square root of 2. So in this case, I'm going to, just like on the previous problem, multiply by 1 in the form of a fraction where the numerator and the denominator are exactly the same. So exactly the same, the number I want to pick is right here, square root of 2. So I make a fraction out of that, I put the square root of 2 over the square root of 2, which is equal to 1. That expression equals 1. So I'm multiplying by 1. In the numerator, I now have a rational factor, 10, times an irrational factor, the square root of 2. So I can't really multiply them together any better than to just say they are two separate factors. And you always want to write the rational factor first, so it's 10 times the square root of 2. Over, like we just did on the previous problem, square root of 2 times square root of 2 by definition equals 2. but most people don't recognize it as such, so just if you have to, say square root of 2 times square root of 2, they're both under square root symbols, so they multiplied equals square root of 4, but then you should recognize that the square root of 4 does equal 2. So you get 10 over the square root of 10 times square root of 2 over 2. I'm just going to write that down below, because just like any fraction that you have, and we still have a fraction here, if there's a common factor between the numerator and denominator, you should cancel it. So just like you reduce something like 6 over 8 by saying 2 goes into 6 3 times and 2 goes into 8 4 times, and it reduces to equal 3/4, we should be able to do the same over here. So there is a common factor between these two rational numbers. 2 goes into 2 once, 2 goes into 10 5 times, and now we have 5 times the square root of 2, the remaining factors in the numerator, over 1. But anytime the denominator is 1, we don't bother to write it. It's understood. So 10 over the square root of 2 simplifies to equal 5 times the square root of 2. Hope that helps. Good luck.